Hey y'all, so in today's video, we will continue our Python for Data Science series and discuss data cleaning and preprocessing. More specifically, I will give an intro, discuss understanding the data set, handling missing values, removing duplicates, data type conversion, handling outliers, data normalization and scaling, feature engineering, data transformation, handling imbalanced data, dealing with multicolinearity, data integration, and some best practices. As always, this video is timestamped, so if you'd like to skip to a specific section, there was a lot of topics we're gonna go through, feel free to by clicking on the timestamp down in the description. So let's get right into it and let's tech talk with Tyler. So let me give you an introduction to data cleaning and preprocessing. Data cleaning is a critical step in the data science process. It involves identifying and correcting errors or inconsistencies in the data to ensure its quality and reliability. High quality data is essential for accurate analysis and decision making. Without proper data cleaning, your results can be misleading or incorrect, and we do not want that. So throughout the tutorial, we will go through each of these steps. I know there were a lot. In detail, provide practical examples and code snippets to help you understand and apply these techniques. The first step in any data analysis project is to load the dataset into a Pandas data frame. Just a brief overview, Pandas provides several functions to read data from different file formats. The most commonly used functions are pd.read_CSV for CSV files and pd.read_Excel for Excel files. These functions allow you to import your data into a data frame, which is a powerful data structure for analysis. To load data from a CSV file code snippet example, we are reading data from a file named data.csv and storing it in a data frame called df. To load from Excel file, the code snippet, we read data from a file named data.xlsx, Excel format, and save it to a data frame called df. So once the data is loaded into a data frame, it's important to perform initial exploration to understand its structure and contents. This helps you get a sense of what the data looks like, what are you even looking at, and identify any immediate issues that need to be addressed. Pandas provides several methods for this purpose, and if you watch my previous video, you'll kind of understand this a lot more. But no worries, I got you. So the head method displays the first few rows of the data frame. By default, it'll show the first 5 rows, but you can specify the number of rows to display as an argument. This method is useful for quick inspection of the data and ensuring that it has been loaded correctly. The info method provides a concise summary of the data frame, including the number of non-null entries, data types, and memory usage. This method helps you understand the structure of the data frame, the data types of each column, and the presence of any missing values. The describe method generates descriptive statistics of the data frame, such as the mean, median, standard deviation, and percentiles for numerical columns. This method gives you a quick overview of the distribution and central tendencies of the numerical data in the data set. So by using these methods, you can perform an initial exploration of your data set, gaining insights into the structure and contents. This exploration is a crucial step before diving into more detailed data cleaning analysis tasks. These initial steps ensure that you start with a clear understanding of your data, setting the stage for effective data cleaning, preprocessing, and analysis. So missing values can occur in data sets for various reasons, such as data entry errors or incomplete data collection. Identifying missing values is the first step in handling them. Pandas provides several methods to detect missing values in a data frame. Let's go through them. The isNull method returns a data frame of the same shape as the original with Boolean values indicating whether each element is missing, such as true or not. False. By chaining this sum method with isNull, you can get the total number of missing values in each column. And this is helpful as it allows you to quickly see which columns have missing values and how many. So once you've identified the missing values, you need to decide how you want to handle them. There are 2 primary strategies you can use. Number 1, removing the missing values. This approach involves removing rows or columns that contain missing values. It's straightforward, but can result in a loss of valuable data if too many values are missing. The second option is imputing missing values. So this approach involves filling in the missing values with substituted values, most often the mean, median, or mode of the column. This preserves the data but requires careful consideration to avoid introducing bias. To remove rows or columns with missing values, you can use the drop NA method. By default, this method removes any row with at least one missing value. Imputing missing values involves replacing them with substituted values. The fill_NA method is used for this purpose. So you can fill missing values with a special value or use statistical measures such as the mean, median, or mode. These techniques help you handle missing values effectively, ensuring that your dataset is complete and ready for analysis. Handling missing values is a crucial step in the data cleaning process, as it directly impacts the accuracy and validity of your analysis. So with these methods and strategies, you can manage missing data effectively and ensure that your dataset is well prepared for further analysis and modeling. Duplicate rows in a dataset can skew analysis and lead to incorrect conclusions. Identifying duplicates is an important step in data cleaning to ensure the dataset's integrity. Pandas provides the duplicated method to detect duplicate rows. The duplicated method returns a series of Boolean values indicating whether each row is a duplicate as true or not, showed as false. By default, it'll consider all columns to determine duplicates. You can also specify certain columns to consider for detecting duplicates by passing them as arguments to the duplicated method. This will result in only considering those specified columns when identifying duplicates. So say you have some columns that you know are duplicates, don't include those. Once you've identified duplicate rows, the next step is to remove them. The drop_duplicates method is used to remove duplicate rows from the data frame. By default, it keeps the first occurrence of each duplicate row and removes the subsequent ones. The inPlaceEqualTrue parameter modifies the data frame directly, so keep that in mind. You can also specify certain columns to consider for removing duplicates by passing them as arguments to the drop_duplicate method. And again, this will only consider the specified columns when removing the duplicates. So by identifying and removing duplicates, you ensure that each record in your dataset is unique, which is pretty important for accurate analysis and modeling. Handling duplicates is a straightforward but vital part of the data cleaning process, as this process helps maintain the integrity of your analysis and avoid potential bias in your results. Understanding the data types of your columns in your data frame is crucial for effective data analysis. Different operations and functions are applicable to different data types. Pandas provides the dtypes attribute to check the data types of all columns in your data frame. The dtypes attribute returns a series with the data type of each column. This helps you understand the current data types of your columns and identify if any need to be converted or changed. A lot of times I have date time that needs to be converted because they start off as objects. Sometimes you may need to convert the data type of certain columns to perform specific operations or analyses. The asType method allows you to convert the data type of columns in a data frame to the specified type. For example, to convert a column to an integer data type, you will use the asType method with int value in the parentheses. Categorical data is a type of data that can take on a limited, fixed number of possible values. So converting columns to the categorical data type can improve memory usage and performance, especially for large datasets with repeated values. Pandas provides the asType with category in parentheses method to convert columns to the categorical data type. So by checking and converting data types appropriately, you can ensure that your data frame is optimized for analysis and that operations on the data are performed correctly. Converting data types, especially to categorical types when appropriate, can significantly enhance the performance of your data processing tasks, and it just makes it easier for you. Outliers are data points that differ significantly from other observations. Identifying and handling outliers is crucial because they can skew analysis results and lead to incorrect conclusions. Happened to me multiple times. There are several methods to detect outliers, including statistical methods such as the IQR, also known as interquartile range, and z-scores. So the IQR method identifies outliers as data points that fall below quartile 1 minus 1.5 time interquartile range or above quarter 3, blah, 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 where quarter 1 and quarter 3 are the first and third quartiles, respectively. So using the z-score method identifies outliers as data points that are more than a specified number of standard deviations, typically 3, away from the mean. Once outliers are identified, you can handle them by either removing them from the dataset or capping their values to reduce their impact. To remove outliers identified using the IQR method, as shown in the code snippet, this code filters out the rows that contain outliers. Alternatively, you can cap outliers by setting their values to the limits defined by the IQR method. The clip method is used for this purpose. This method sets the values below the lower limit to the lower limit and values above the upper limit to the upper limit. By identifying outliers using statistical methods and deciding whether to remove or cap them, you can maintain the integrity of your data and improve the accuracy of your analysis. Normalization and scaling are essential pre-processing steps in data analysis and machine learning. These techniques ensure that features contribute equally to the analysis and improve the performance of algorithms. Many machine learning algorithms are sensitive to the scale of the input features. Features with large ranges can dominate the objective function, leading to suboptimal performance. Normalizing and scaling the data ensures that all the features are on a similar scale. There are two common techniques for normalization and scaling. The first one is min-max scaling, and the second is standardization. So for min-max scaling, also known as normalization, scales the data to a fixed range, typically 0 to 1. This is done by subtracting the minimum value of each feature and dividing by the range. The min-max scaler from scikit-learn can be used to apply min-max scaling to your data. So the code snippet example that you see on the screen scales the specified columns to the range 0 to 1. Standardization, also known as z-score normalization, scales the data to have a mean of 0 and a standard deviation of 1. This is done by subtracting the mean of each feature and then dividing by the standard deviation. The standard scaler from scikit-learn can also be used to apply standardization to your data. The code snippet for this standardization standardizes the specified columns to have a mean of 0 and a standard deviation of 1. So by normalizing and scaling your data, you ensure that all features are on the similar scale, which helps you improve the performance of any machine learning algorithms and the accuracy of your analysis. Feature engineering is the process of creating new features from existing data to improve the performance of machine learning models. By generating these new features, you can provide more relevant information to the model, leading to better predictions. You can create new features by combining existing ones or applying custom functions. You can create new features by combining existing features in various ways, such as addition, subtraction, multiplication, and more. So the code snippet on the screen creates a new feature called combined_feature by adding the values of feature 1 and feature 2. The apply method allows you to apply custom functions to data frame columns or rows to create new features. The code snippet that you see on the screen creates a new feature by applying a custom function to multiply the values of feature 1 and feature 2 for each row. Feature extraction involves deriving new features from existing data, such as extracting specific components from datetime data. This helps in converting raw data into more meaningful information. Let's say you have a date time column. You can extract specific components like year, month, day, etc. using the DT assessor. This code snippet extracts the year, month, and day from the date_ column and creates new features for each component. Categorical variables need to be converted into numerical format before they can be used in machine learning models. There are two common methods to encode categorical variables: PD get_dummies and label encoder. So using the get_dummies function will convert categorical variables into a set of binary variables, 0 or 1. This code converts the categorical underscore column into multiple binary columns, each representing a unique category. The label encoder from scikit-learn converts categorical labels into numeric labels. This code converts the categorical underscore column into numeric labels and stores them in a new column called encoded underscore column. So by creating new features, extracting meaningful information, and encoding categorical variables, you make your life easier, number one, and you can enhance your data set and improve the performance of your machine learning models. Data transformation involves applying mathematical functions to your data to stabilize variance, normalize distribution, and improve the performance of your models. Log transformation is used to reduce skewness and stabilize variance in data. It is particularly useful for data with a wide range of values. applying a log transformation can help normalize the distribution of the data. So the code snippet here applies a log transformation to the column and stores the result in a new column called log_transformed. Square root transformation is another technique to reduce skewness and stabilize variance. It is often used when dealing with count data or data with moderate skewness. So this code snippet applies a square root transformation to the column and stores the result in a new column called sqrt_transformed. The apply method allows you to apply custom transformation functions to data frame columns. This is useful when you need to apply more complex or specific transformations to your data. This code snippet applies a custom transformation function to the column and stores the result in a new column called custom_transformed. Replace custom_function with the function you want to apply. Data transformation is a key step in the data preprocessing pipeline, enabling you to enhance the quality of your data and improve the performance of your analysis. I think you kind of get the gist. Everything that we're going up to leads to better analysis and better models. So by understanding and applying these techniques, you can handle a wide range of data challenges effectively. In many real-world data sets, the classes are not evenly distributed. This class imbalance can lead to biased models that perform poorly on the minority class. So identifying imbalanced data is the first step in addressing this issue. To detect class imbalances, you can use the value_counts method to count the occurrence of each class in the target variable. This code snippet provides a count of each class in the target variable, helping you identify if there is an imbalance. Once you've identified an imbalance in your data set, there are several techniques to handle it. The most common methods are oversampling and undersampling. So what's oversampling? This involves increasing the number of samples in the minority class to balance the data set. This can be done using various techniques such as SMOTE, synthetic minority oversampling technique. This method generates synthetic samples for the minority class by interpolating between existing samples. This helps create a more balanced data set without duplicating existing samples. So this code applies the method to the feature matrix X and the target vector Y, generating a new balanced data set. The next one is undersampling, which involves decreasing the number of samples in the majority class to balance the data set. So this can help create a more balanced data set by reducing the number of samples in the overrepresented class. The random undersampler from the imbalearn library can be used to randomly remove samples from the majority class. So this code applies random undersampling to the feature matrix X and the target vector Y, generating a new balanced data set. Multicolinearity occurs when two or more independent variables in a regression model are highly correlated. This can make it difficult to determine the individual effects of each variable on the dependent variable and can lead to unreliable and unstable estimations of regression coefficients. So understanding and addressing multicolinearity is crucial for building robust regression models. There are several methods to detect multicolinearity in your data set, including the correlation matrix and variance inflation factor, also known as VIF. The correlation matrix helps identify pairs of highly correlated variables. Values close to 1 or -1 indicate strong correlation, 1 being a positive and -1 being a negative correlation. So the code snippet here generates a correlation matrix for the data frame DF, allowing you to inspect the pairwise correlations between variables. Now onto the VIF, the variance inflation factor. This quantifies how much the variance of a regression coefficient is inflated due to multicolinearity. A VIF value greater than 5 or 10 indicates high multicolinearity. So the code snippet here calculates the VIF for each feature in the data frame DF, providing a measure of multicolinearity. All right, we've identified multicolinearity. What's next? Now you need to address it to ensure the stability and reliability of your regression models. There are two common approaches you can use: dropping the correlated features and using dimensionality reduction techniques like principal component analysis, or PCA. So the first option, dropping correlated features, is one way to handle multicolinearity. And basically, you drop one of the correlated features from the data set. Shown on the code snippet, you remove the correlated underscore feature column from the data frame, helping to reduce multicolinearity. The next option is using PCA, or principal component analysis. And this is a dimensionality reduction technique that'll transform the features into a set of linearly uncorrelated components. And this helps reduce multicolinearity while retaining most of the original variability in the data. So this code applies PCA to the feature matrix X, reducing it to the specified number of components and helping to address multicolinearity. So by understanding and addressing multicolinearity, say that 3 times, you can build more robust and reliable regression models. Detecting multicolinearity using the correlation matrix and VIF and handling it by either dropping correlated features or using PCA ensures that your models can perform well and provide accurate estimates. Data integration involves combining data from multiple sources into a single cohesive data set. This is a crucial step in data preprocessing, especially when working with data from different files or databases. Pandas provides several functions to combine data sets, including merge and concat. And they're pretty simple. I think you've heard of them before. The concat function is used to concatenate 2 or more data frames along a particular axis on the rows or columns. So in this code snippet, the code concatenates data frame 1 and data frame 2 along the rows, which is axis equals 0, resulting in a combined data frame. The second option is the merge function, and this is used to merge 2 data frames based on a common key column. It's similar to SQL joins. So as you may know, if you've done SQL before, you could handle different types of joins. Joins are used to combine data sets based on common keys. There are several types of joins, each serving a different purpose. I'm gonna go through them. If you already know about SQL joins, you could skip through this. So the inner join, and that returns only the rows with matching values in both data frames. An outer join returns all rows from both data frames with nulls where there is no matches, and the nulls are shown as NaN. A left join will return all rows from the left data frame along with the matching rows from the right data frame. If there are no matches, nulls are returned for columns from the right data frame. A right join returns all rows from the right data frame along with the matching rows from the left data frame. And again, similar to the other ones, if there are no matches, nulls are returned for columns from the left data frame. So by combining multiple data sets and handling different types of joins, you can integrate data from various sources into a single cohesive data frame. So therefore, data integration is a fundamental step in the data preprocessing pipeline, allowing you to consolidate data from different sources. That's all that I have. I hope you have a better understanding of Python cleaning and preprocessing techniques than you did a couple of minutes ago. If you have any questions, comments, or any other Python related video topics, leave them down in the comments. I'll check it out. Also, if you aren't already, subscribe to my channel. It's free. And click the bell icon to be notified when I post again. Thanks again for interacting with Tech Talk with Tyler, and I'll see y'all later. Peace.